Hello, this is Pat Kelly. In this problem, they ask us to use Green's theorem to evaluate this integral. And the region is the area bounded by these two curves. These are what they gave to me, the y equals 1 minus x squared, and also the y equals 0, your x-axis. And I've drawn them for you ahead of time. And I'd probably suggest in these problems, you go ahead and give yourself a sketch, mostly just as a visual, okay, so I can see what's on top and what's on bottom and left and right and all that business, okay? But of course, the real heart of the problem is going to be over here where we actually use Green's theorem. And you've got to love Green's theorem. I mean, I'm telling you that's a mandate. You have to love Green's theorem. It's wonderful. It makes these integrals so easy. Here's the setup for Green's theorem, is that this integral will end up equaling the double integral over the region of the partial of n with respect to x minus the partial of m with respect to y. And you're familiar with what we mean by n and m. We've done enough problems where those were involved. Those are just your components here and here, m and n. And then dA, some kind of differential element for that area. And the reason why you love Green's theorem then is all you need to do is a couple of partials and then you integrate, like back from Calc 1 or maybe Calc 2. So my partial of n with respect to x, let me get going here with my double integrals. But my partial of n with respect to x is this guy differentiated with respect to x is just 1 minus from the theorem. And then partial of m with respect to y, that's right here. Differentiating with respect to y is just 2x. It looks good. And then my dA, that differential element of the area, since everything's going to be in terms of x's and y's, I don't have any y's right here, but with these partials, you could have x's, you could have y's. You're going to do a dy dx. Your area is going to be like x times y type of idea. And which one comes first, you have some flexibility, but what I'm looking ahead at now then is your limits of integration. If I do the y first in my integration, now I look to my graph, and in terms of the y's, they go as low as 0 and as high as this curve, which is a function of x, which is why I want my y variable to be integrated first so that I can go from 0 to 1 minus x squared. That'll put everything in terms of x. So then when I go and integrate with respect to x, back to the graph, all I need to worry about is a low value of -1 and a high value of +1. So from -1 to 1. Okay, now you're set to go in terms of the integration. Let's do the inner layer first. So keep that -1 to 1. If I integrate this with respect to y, we're going to get y minus 2xy, which I'll need to evaluate from 0 to 1 minus x squared. My limits of integration there for y. And then there's going to be a dx still in that integral. So this equals, let's plug in our limits of integration. I still have integral -1 to 1, my y, 1 minus x squared, when I plug in the top, minus 2x, 1 minus x squared. Okay, and then, I'm not going to write parentheses for this, then you would subtract what happens when you plug in the lower limit for y, which is going to be a 0 here and a 0 there. Okay, so then just close these parentheses here though, so I can get my dx going. All right, looks good. Let me slide over here just for some more space. Before I actually do the integration, I think I'd like to combine like terms and see what all I'm looking at here. Is I do have minus x squared. Here's an x, here's an x cubed. Okay, so just minus x squared. And then I guess this 1 has no other like terms. Minus 2x. I was looking for like terms. I don't see any like terms, but I've got everything spread out as a polynomial. which looks good for my integration. I'll slide over again and just do that integration. Minus x cubed over 3 plus x minus x squared, and then plus x to the 4th over 4, so x to the 4th over 2, after we multiply by that 2. Okay? And all of that is evaluated from -1 to 1. A little bit more work, but it's really just arithmetic at this point. Let's put in that top value of 1 minus 1/3 plus 1 minus 1 plus 1/2. And subtract what happens when we plug in the lower limit. -1s, that's going to be a -1/3, but actually positive, with that minus in front. Minus 1 minus 1 plus 1/2. This equals, this is not too involved with the fractions. I'm just going to grab a calculator to make sure that I get it right, especially because I'm running out of room there. Might be just as easy to do it in your head, though. Plus 1. So I'm getting approximately 1.333 repeating. So let's say that that equals 4/3. Final answer. Okay, hope that helps. Do some more problems. You'll appreciate Green's theorem too.